So in this problem, we need to verify that the condition n squared equals to a squared times l squared plus m squared is followed whenever a circle x squared plus y squared equals to a squared is touched by a line. This equation is given to it. Let's begin. So here we will consider a circle. So this is the circle which is centered at C, and if we compare the circle with the standard form, then it immediately tells us that the coordinates of the center is going to be at the origin, and it has a radius of a unit, and we have a line which is touching the circle at a particular point, or we can say this line is tangent to the circle, let's say at point A. So if this is if this is true, then we need to verify that n squared equals a squared times l squared plus m squared. How shall we do that? So what we'll do, we'll first try to find out the distance of point C from the line which is given by the equation Lx plus my plus n equals to 0. There's a standard formula for finding out the length CA. So CA will be equals to, all we have to do is take the absolute value, and then we'll have to take a ratio inside the absolute value. We'll first begin by considering the x coordinate of point C, which is 0. To it, we are going to multiply the coefficient of x of the line, so that's simply L. And next, what we'll do, we'll add this value to the y coordinate of the center, so that's 0. 0 will get multiplied to the coefficient of y, which is m. And added to it will be simply the constant term, so that's n, divided by the square root of, now underneath the square root, we'll have to consider the coefficient of x and coefficient of y, which are L and m. What we'll do, we'll square them and add them to each other. So we have L squared plus m squared, which means this comes out to be equals to n divided by square root of L squared plus m squared. This is the length CA. However, what is CA? CA is nothing but the radius of the circle. And from this particular equation, the x squared plus y squared equals to a squared. Clearly, the radius comes out to be a unit, which means that CA, which is nothing but the radius, is also a unit. What we can do, we can take this absolute value to be equals to a. So let's get rid of the absolute value by squaring both sides. So we get a squared equals to n squared divided by l squared plus m squared. Now when we rearrange the terms, we get n squared equals to a squared multiplied to l squared plus m squared. So we have obtained the condition which is verifying the fact that the circle is indeed being touched upon by the line whose equation is given to us at a point A, or we can say that the line is tangent to the circle whose equation is x squared plus y squared equals a squared.